Hello students, we are starting the second 6 weeks today of the fall 2020 semester, and this is lesson 2.1.2, which if you remember, this means second 6 weeks, first week of the second 6 weeks, and this is the second day because yesterday we had a teacher work day, so that's why it's 0.2 instead of 0.1. We are going to be covering a unit over the next 2 weeks. This Friday, you will have a quiz on what we do today, tomorrow, and Thursday. There won't be a review day this week, but there will be a review day next week on Thursday. But next week's test on Friday will cover everything we do this week and next week. It might seem like we're going a little bit fast, but a lot of what I'm going to be covering, you should have started in middle school. So a lot of it is going to be a review, and you're going to remember it. And then some of it will be new. For some of you, more of it will be new than for others because some of you had more of Math 1 than others did. It just depends on how you took Math 1 and whether you had Math 1 last fall or last spring. So bear with me and just keep an open mind here and try to stay with me. If you remember also, last week we discussed me doing videos for the classwork as opposed to doing the live lessons and doing the classwork during the live lesson. So what you'll notice is that there's a video here for you for the notes, and then also on the classwork there will be a video. That doesn't mean you don't need to come to the live lesson. I will still give you extra credit for coming to the live lesson. So after you finish these notes, as long as you're on time, our live lesson will still be at 2:45. But what I'll be doing during the live lesson time is just for a few minutes I'll be talking to you about what you did during the notes and then what you'll be doing for the classwork. I may also move that live lesson up a little bit depending on how we do with the notes videos. Right now, just plan on it being still at 2:45 because I think that's a good time for us. So if you show up for the live lesson, you'll still get your point extra credit on your quiz or on your test for that week. And you'll just hear, any kind of announcements or anything else. But it'll only be about 5 minutes for each live lesson, so be sure you get there on time. Okay, so let's get started. This is the notes, again, 2.1.2, and this is basically polynomial operations is what this is. I'm going to be using some voice to text in these boxes here where we do definitions. I might also try it out in some of these example boxes, and you can do it in one of two ways. You can pause your video and you can use your own voice to text. You might be able to use voice to text using my voice. If you're following along with me and you're splitting your screen, you could probably do that. So you could pause your video and start your own voice to text and use it as well. I don't know how well that will work out for you, but you can certainly try it. So talking about polynomials, what is a polynomial? So this is one place I'm going to use my voice to text. I'm going to use my text box. If you use the text box, do a different color, like do red or purple or blue or something so I can see that you've actually put something in there. So I'm going to click my microphone and then I'll start the definition. Expressions that are made by adding and subtracting terms. Okay, so that was the definition of a polynomial, and then I'm going to make it fit in this box by dragging that over. And then I think, let's see, maybe I'll just try to use it again over here. Let's see what happens. So some examples of a first degree polynomial. Polynomials have what we call degrees, and it really has to do with the exponents in the polynomial. It has to do with the highest exponent. So let's see if we can use our voice to text here too. 3x plus 1, comma, y, comma, 4a plus 2b, comma, 7x. So that kind of worked, except right here it typed the name or the word y instead of the letter y. Let's just go back and correct that. And then it did capital B and capital X. That's okay. I wouldn't mind too much if it had that, but I'll go back in and put a lowercase b at least. Okay, so these are some examples of what we call first degree polynomials. So we have a 3x plus 1. The x is the highest degree there is a 1. In other words, it doesn't have an exponent of 2. It doesn't say 3x squared plus 1. 3x squared plus 1 would be a second degree polynomial. Let's see what it does on the second degree ones. Let's see if it'll type those in like it should. 2x squared. comma. Nope. It won't do that one right, so we'll get rid of that. And I'm going to write those in. Okay, so some second degree polynomials. One example would be 2x squared. And again, I want this in a different color. I'm going to do red. Another one would be 8x squared plus x. X squared plus 6. So all of these, you see, have a 2 as the highest exponent. That's called second degree. Third degree, as you can probably guess, would have a 3 exponent. So something like x cubed plus x. These are not like terms, so I can't add them together. 2x cubed plus 4x squared plus 1. That would be a third degree polynomial, because the highest degree or the highest exponent is 3. And then one more, 5x cubed plus 9x minus 3. Okay, so again, that's a third degree. An example of a fourth degree, anything with the exponent 4, 2x to the fourth plus 2, x to the fourth plus 7x, 2x to the fourth minus x cubed plus 1. Any of these are fourth degree polynomials. Okay, so how do you add polynomial expressions? Let's do our voice to text here. How do we add polynomial expressions? You combine like terms by adding the coefficients of the terms. Okay, so let's talk about what that looks like. So let's say we had something like, and I'm going to put these in parentheses because that's how it shows on my paper, 2x squared plus 3x plus 7 plus x squared plus 9x plus 6. Okay, so what we would do is we would look for what we call like terms. Okay, so like terms means they have the same exponent. Okay, so one like term would be 2x squared and x squared. Those are like terms. Another one, let's get a different color, would be the 3x and the 9x. Even though there's parentheses here, there's a plus between them, so we're adding all these. And then the last set of like terms would be the 7 and the 6. And you can actually also highlight the operation symbol before each one of those. That's purple. Because you want to make sure that you add or subtract in the correct way. All right, so let's combine these like terms. So the green like terms, 2x squared plus x squared, that's a 1 right there. So remember, that's 2x squared plus x squared, that's 3x squared. And then the purple ones, 3x plus 9x is plus 12x. And the red ones, 7 plus 6 is plus 13. So that's how you would do that. I like to use highlighters. You can also group them together if you want to, but I like to use highlighters for mine. How do you subtract two polynomial expressions? Okay, so again, I'm going through this kind of fast. There is a long, drawn-out explanation on my key, and I am going to put that in here, but remember, we're using voice to text where we can, so go ahead and do that if you can, because it's going to be a lot easier than trying to type in here. Okay, here we go. First, comma, change the problem into an addition problem by changing the subtraction sign to addition and changing the signs of all the terms that follow the subtraction sign to their opposites, period. Then, comma, combine the like terms by addition, the coefficients of the terms. Okay, so there was an error in mine. It said addition, and it should have said, it should have said adding. I'm going to change this to adding. Okay. All right, I don't have, capital letters here or anything, but that's okay. I'm fine with the way it looks. Okay, an example of this. Let's do 2x squared plus 3x plus 7. This looks like the one above it. Minus x squared minus 9x plus 6. Okay, so just a little bit different. So what it says is first change the problem into an addition problem. So I'm going to get a different color here. I'm going to change this to a plus. Okay, and then I'm going to change everything in the parentheses to the opposite of what it was. So this is going to become a -1. This is going to become a +9, and this is going to become a -6. Okay, so then I'm going to highlight my like terms. 2x squared and -x squared are like terms. +3x and +9x are like terms. And my +7 and my -6 are like terms. So I'm going to do what we call combine, which means add or subtract them, whichever, depending on what, operation symbol they have. Okay, so 2x squared minus x squared, that's 1x squared, or just x squared. And then 3x plus 9x plus 12x. And then my last one is green. 7 plus -6, or 7 minus 6 is +1. Okay, so that's how we would do that. And so I went ahead and put the examples for the next section on here. Sometimes we have to solve equations where we've got like terms on one side or both sides, and we want to combine those like terms before we do anything with the equation, before we try to isolate the variable. So that's what this is. So if I were to highlight my like terms, 6x and -2x are like terms, and 9 and 5 are like terms. So again, you've done all this. I'm just kind of reviewing. So that's going to be 4x plus 14 equals 38. And then subtract 14. 4x equals 24. Divide by 4 on both sides. X equals 6. Over here, we would change this to a plus. We would change both of these to the opposite of what they were. 9x minus 3x, 6x. 10 minus 2 plus 8 equals 74. Subtract 8 on both sides. 6x equals 66. Divide by 6, x equals 11. So that's just showing you two examples of equations where you have to simplify on one side or the other by combining like terms before you solve the equation. Or you don't have to, but that is the best way to do that. Okay, so we also want to look at distributive property, and I'm going to use my text box again and my microphone. Multiplying a term by every term in the parentheses that follow the term. Okay, so let's talk about what that looks like. A single term multiplied by a binomial. 3 times x plus 2. What we do is we distribute that 3 into the parentheses and we multiply it by everything in the parentheses. So this is going to be 3x plus 6. X times 2x plus 6. Okay, so we've got a variable times everything in the parentheses. X times 2x is 2x squared. And then x times 6 is 6x. We don't have any like terms we can combine or anything, so we leave it just like that. Multiply a term by a binomial. 6x times 5x plus 7. 6x times 5x is 30x squared. Remember, if you multiply x times x, that is x squared. And then 6x times 7 is plus 42x. So that would be the simplified version of that. And then the last one, it's kind of long. I paused my video just to kind of save a little bit of time. 8 times 2x to the 4th, that is 16x to the 4th. 8 times x cubed plus 8x cubed. 8 times, so we multiply the coefficients. 8 times 4 plus 32, and that's x squared. 8 times 8x plus 64x, and 8 times -6 minus 48. All right, so that would be the simplified version of that. That's just distributive property, where you distribute that term, whatever it is, that's on the outside of the parentheses, and multiply it times everything inside the parentheses. So I went ahead and wrote these two examples. This is distributive property, solving equations by distributive property. We just did a few distributive property problems. In this case, there's no plus or minus between this term and the parentheses. So this means we multiply, we distribute this 8 in. So we need to get rid of parentheses first. Actually, we don't have to. We could solve this by dividing by 8 on both sides. But I just want to show you distributive property, so I'm going to do it that way. So this is 8x minus 16 equals 32. Add 16, 8x equals 48, and then divide by 8, x equals 6. The other thing we could have done, like I said, is divide by 8 on both sides, and that would have made that a lot easier, but we're showing distributive property, so we want to do that. Okay, just distribute the 3 in. That's going to be 3 times 3x, 9x, plus 3 times 5 is 15. 2 times 6x is 12x, times 2 times negative 3, negative 6. And then I'm going to, the easiest way to do this one is to subtract 9x and add 6. So that cancels right there. 15 plus 6 is 21. They did it differently on my key, but that's okay. These cancel, and then 12 minus 9, 3x. Divide by 3 on both sides. X equals 7. Okay, so again, this should all be review for you. I just wanted to go through these before we talk about factoring. Okay, what is factoring? Text box, microphone. Breaking down a polynomial into the product of other polynomials. Okay, so what we just did up here with the distributive property, we're going to be kind of doing the opposite of that. Okay, let me show you what I'm talking about. All right, so let's look at an example. Let's say we have something like, this is one example, 6x minus 30, okay? So what we want to do is we want to look at both of these terms. Let me use my highlighter. So I want to look at both the 6x and the negative 30, okay? And I want to ask myself, do they have a factor in common? Now I want you to remember what a factor is. A factor is a number that will divide into it, okay? So both of these have a 6 in common. Now there is one way you can do this, and this is what's shown on my key. And what they do is they take each of these numbers and they break it down into its factors. Okay. Let's do this purple. And then I'll do the minus. And then, okay, so 6x can be written as 6 times x. 30 can be written as 6 times 5. And what they're trying to do is they're trying to get one where I've got a number in common here. The other thing you can ask yourself is, what do these have in common? Like, what factor do 6 and 30 have in common? You might also sometimes use, variables, but both of these don't even have a variable. So the factor that they have in common is the one that we've put here too, the 6, okay? So what we say is basically we talk about pulling out that 6, right? And what we're doing is the opposite of distributive property. So what I want to end up with is I want to end up with a term here and then something parentheses. Okay, so a term here and a term here. So I want to end up with the opposite of distributive property. Well, I want to end up with the distributive property here, basically. So when I talk about pulling out the 6, I mean I'm putting the 6 on the outside of the parentheses. Okay, and then what goes on the inside of the parentheses is the x minus 5, because I've already taken care of the 6. So I've got x minus 5 left over, x minus 5. But let me show you another way to do this. Let me erase this right here. If I can recognize that 6x minus 30, that 6x and 30 have a 6 in common, what I'm really doing is when I figure out that they have a 6 in common, I'm dividing each of these by 6. So 6x divided by 6, these 6's cancel out, is x, okay? And then 30 divided by 6 is 5. Okay, so that's what goes in the parentheses, the x and the 5. And then this thing stays the same, whatever that is. So that minus stays the same. So that's basically what I'm doing there. All right, I can do the same thing with a trinomial. But let me show you a couple more binomials first. So let's say I had something like 2a plus 8. Okay, so I'm looking at the 2a and the 8, and I'm asking myself, what factor do they have in common? What's the greatest common factor between those things? And it would be 2, because 2 divides into 2 and 2 divides into 8. So I would pull out the 2. I would take out the 2 and do my parentheses. And then I take each of these terms and I divide it by 2. I meant to do that in red. So 2a divided by 2 is a. And then my plus, that always stays the same. And then 8 divided by 2 is going to be 4. So that would be my answer. And if you think about it, if I distribute this back in, 2 times a is 2a, 2 times 4 is 8. So I would get the same thing. I'm doing the opposite of distributive property. Let me just show you one more. Let's do 3x plus 9. Okay, so what's the greatest common factor of 3x and 9? 3. That goes outside the parentheses. And then just divide. What's 3x divided by 3x? Okay, 3 divided by 3 is 1, and x divided by nothing, or 1, is x. And then 9 divided by 3 is 3. So this would be my factored form, these things. And then up here, my factored form would be there. So all I'm doing is I'm taking a greatest common factor out of that expression. Okay, let's look at another one. Let's say I have 12x minus 28y plus 8z. Okay, so if I have x, y, and z, first of all, I don't have any kind of a variable that I can use. There's no letter that I can use in my greatest common factor. What I'm looking for here is I'm looking for a number that'll divide into 12, 28, and 8. And what I'm thinking about is 4. Okay, so let's try the 4. And let me show you again how I showed you up there above. So if I take a 4 out of this 12, 12 equals 4, or 12x, sorry, equals 4 times 3 times x, okay? And then I put my minus there. 28 equals 4 times 7 times 28y, sorry, times y. Plus 8z is 4 times 2 times z. Okay, so what I did was I found that, okay, they all have that 4 in common. So I can take the 4 out. So they have this in common. So I'm going to put that on the outside of the parentheses because that is what I basically factored out, so to speak, okay? And then what goes on the inside of parentheses is this 3x. So again, what do I have left after I take that 4 out? So when I take that 4 out, it's gone, okay? So what's left? My 3x, and then my minus stays the same. So I got a minus there. It's my 7y, that's 7 times y, that's 7y. And then my plus stays the same. And then my 2 times z, which is 2z. All right, so that is taking that factor out. That's how you do that. You take that 4 out, and then what's left over is what goes in parentheses. All right, let's try another one. Factor a common factor variable out of a binomial. Let's see what we've got here. We've got 12x squared plus 5x. Okay, so first of all, I look at my coefficients, my 12 and my 5. My 12 and my 5 don't have any factors in common, so I really can't take anything out of that. But my x squared and my x, if I look at this and this, anytime you have the same variable and like different exponents, you take out the one that has the lowest exponent. So I know I can take out an x. Well, let's rewrite this. Let's rewrite 12x squared as 12 times x, okay? And then I'm going to do a different color and write 5x, put that plus in there. 5x is 5 times x. Okay, so what factors do I have in common from the green part to the red part? I have an x in common. So that's one way you can do this. So I'm going to, I'm going to highlight the x that they have in common. Okay, so that's basically what we're talking about, taking out or pulling out. When we talk about pulling the factor out of it, that what they have in common is what we're going to take out. Okay, so the x, when I say take out, I mean take out of those parentheses. Okay, so once I do that, I'm done with that. So I'm going to mark it out so it doesn't look like another x. So I'm done with it. So what's left in my parentheses? I've got 12x, and then my plus right here, that stays the same. And then I've got 5 plus 5. Okay, again, if I were to do distributive property and multiply the x times everything, I would end up with my original expression. All right, let's try another one. Factor a common factor out of a trinomial. Let's see, what are they giving me? Let me do this in red. Actually, I think I'll do this in black. Then I can use my colors. 5xy squared. Okay, so the y is what's squared. Plus 6y plus 7y squared. Okay, so 5, 6, and 7, again, there's nothing that will divide into all three of those. So I'm going to break these up. I'm going to break this 5 up. Let's do a different color into 5 times x times y times y. And again, I'm listing that y twice because it's to the second power. And then I've got plus and then we'll do blue, 6 times y, okay? And then plus, then let's do green here, 7 times y times y. Okay, so I have to have something that is in all 3 parentheses. And the only thing that's in all 3 parentheses is 1y. Oops, that is way too light. There we go. Y there, and a y there. So that's what I'm taking out. That's what I'm pulling out of the all 3 parentheses. So when I put that y on the outside of the parentheses, it's gone. I've dealt with that. I can mark it out. Okay, so what's on the inside of the parentheses? 5 times x times y, you just write 5xy. And then the plus, and then 6 times nothing is just 6. We don't want to say nothing because that would be 0. And then our plus again, which is right there. And then 7 times y is 7y. All right, so that's how you do that. Okay, so this is the last one we're going to do like this. And then we're going to do some multiplying, and I think you've probably seen this before, but we're going to talk about that. All right, so I've got a 12x cubed, a negative 9x squared, and a 6x. I'm going to look at the coefficients first. 12, 9, and 3. I know I can take a 3 out of all of those, so I'm going to keep that in mind as I write, as I write these out. So let's do that first. Let's do 12. We're going to make that a product of 3 times 4 times, and then there's 3 x's. X times x times x. Okay. And then I've got a minus 9x squared. Let's see, I want that one to be blue. 9, I'm going to make that a product of 3 times x times x. Okay. And then I've got a plus. And let's do red. 6, I'm going to do 3 times 2 times x. Okay, so this time I have more than one thing in common here. I see a 3 on all of them. I also see an x on all of them. So I can pull out not just the 3, but I can take out a whole 3x. Okay, so when I do that, 3x is on the outside of the parentheses. So this is gone. Don't need to worry about that anymore. What's left? What's left in the parentheses? Okay, so in the green parentheses, I've got 4 times x times x. That's 4x squared. And then I've got a minus. And then 3x in blue. 3x. And then a plus. And the only thing left in red is 2. So 2. So that's actually the factored version of that original trinomial. So our next section is multiplying 2 binomials by the FOIL method. And FOIL method, I can show you what it means. I'm going to show you how to do it, but I prefer the box method, and I'm going to show you that one too. So our first trinomial is x plus 3 times x plus 5. So anytime you have trinomial. Our first set of binomials is x plus 3 and x plus 5, and we don't have anything, a plus or minus between these. So this means multiply them, okay? So the way you multiply them with the FOIL method is you multiply the first term by the first term. Okay, so what's the first term? The first term is the x and the x. So I'm going to multiply the x's times each other. And when I do that, I get x squared, okay? So x times x is x squared. Okay, and then I'm going to rewrite this down here. Then what we do is we multiply the outside terms. The outside terms, a different color, are the x and the 5, okay? So I'm going to multiply the x times the 5 and get 5x. Okay, so all of this is part of what we're going to get when we multiply. So the x squared is part of my answer, and the 5x is also part of my answer. I'm not done. I have to do 4 different multiplications, basically. Okay, multiply the inside terms. Okay, so the inside terms, let me rewrite it. X plus 3, x plus 5. The inside terms are let's do a different color. Let's do that one. The 3 and the x. See how they're kind of they're inside the x and the 5. When I multiply those times each other, I get 3x. And then the last terms. The last terms, let's see. I don't know what color I haven't used. I'll do, oh, I got to rewrite it. X plus 3, x plus 5. The last terms, what we call it, are the 3 and the 5. So they're the last terms in each of the binomials. And when we multiply those, we get 15. Okay, so again, the 3x is part of the answer, and the 15 is part of the answer. So now what I do is I take each one of those and rewrite it. So x squared plus 5x plus 3x. And I'm going to show you another way to do this, like I said. So I think I did, let me make this a little bit smaller so maybe we can see the whole thing. There we go. That might work. Okay, so I take that x squared plus 5x. And you can do this all in one line. You don't have to do it like this. Plus 3x plus 15. And then what I do is I combine my like terms. I have some like terms here. I have the 5x and the 3x. Those are like terms. So when I combine those, my answer is x squared plus 8x, because I'm adding the 5x and the 3x, plus 15. Okay, so I have multiplied those two binomials using the FOIL method. Now, let me talk to you about what we call the box method, and you might have seen this before. The box method means you draw, it's almost like a tic-tac-toe thing. Draw a box, and I'm going to use this line as part of my box. Draw a box with 4 squares, okay? And in each square you put, how do I want to say this? So each of these squares is going to have one of these, the x squared, the 5x, the 3x, and so on. Okay, so across the top, I'm going to put one of my binomials. So x plus 3, x, and then sometimes I write a plus 3 here, sometimes I don't. If it's a negative 3, I'll write a minus. So I'll go ahead and put a plus 3 there, positive 3. And then down the left side, I put my other binomial. So x and then plus 5 or positive 5. Okay, so this is kind of like a multiplication table. So what we do is in this blank right here, you know what, I don't want, let me get rid of that. I don't want to draw a circle there. But in this blank, I will do the x times the x, okay? X times x is x squared. All right, and then in this blank right here, I'll do what lines up with this box, which is the 3 and the x. 3 times x is 3x. And then in this box down here, I will do what lines up in this box, which is the 5 and the x. 5 times x, 5x. And then the last box, let's do green. We'll do what lines up with that box, the 5 and the 3. If you can see the 5 and the 3 line up. So 5 times 3 is 15. Okay, so that's my box method. Then what I do is I just take these in order, x squared plus 3x plus 5x plus 15. I write them down, which is exactly what we did down here. It's just a little bit different order. X squared plus 3x plus 5x plus 15. What you can also do is realize that these two right here are like terms. So you could go ahead and combine those as you write it down. X squared plus 8x plus 15. So I'm just going to tell you, this is my preferred method for doing this as opposed to FOIL. So when you see me doing multiplying binomials together, you're going to see me using box method. But you are welcome to use either method. All right, so let's do some practice. So again, I'm going to be using box method. So let me talk to you about this. Draw your box, 4 squares. Across the top, let's put x plus 3. And that plus 3 just means positive 3. Down the left side, let's put x plus 9. Okay, this square right here, x times x is x squared. X times 3 is 3x. X times 9, 9x. And 9 times 3 is 27. Okay, so I have two like terms here, which are the 9x and the 3x. I'm going to combine those before I write my answer, or as I'm writing my answer. My answer is x squared plus 12x, which is the 9x plus the 3x, plus 27. And that's my answer right there. Okay? We'll make my box over here a little bit. Okay, so this one I have negative numbers, and this is where I want to make sure that I put negative numbers here. So x and then minus 6 or negative 6, x minus 2, which I'd make a negative 2. This is x squared. This is minus 6x. This is minus 2x. And then negative 2 times negative 6 is positive 12. My like terms are the negative 6x and the negative 2x. I want to make sure I combine those. X squared is my first term. Negative 2x plus negative 6x is negative 8x. And then plus 12. Okay, what I want you to do is I want you to pause your video and I want you to try these last two. And then I want you to come back, and when you come back, I will have worked them and you can check your answers. Okay, so the bottom left corner, you should have gotten x squared minus 3x minus 4. And the bottom right corner, x squared plus x minus 56. And I did highlight the like terms there. So this works for binomials when you are multiplying two binomials together, which binomials, we didn't really talk about the names of them, but a binomial is a polynomial that has two terms, like x plus 1, x minus 4, x plus 8, x minus 7. Those are what we call binomials. I am sorry this went so long. I will see you for a few minutes at the beginning of the live lesson, and then I will have a video for you with the classwork.